Okay, so we're working on Camera Fundamentals 3, and we're talking about lenses and optics, and now we're going to go a little bit more in depth into optics. And some important things that we need to think about. So let's look at some optical principles. The first is, what actually is focal length? What does that mean in terms of the camera? Imagine, if you will, if I have a subject here, like Albert Einstein, and if I have a very simplified view here of the camera, the image plane where the image is created inside the camera on the digital sensor, and then the lens that sits in front of that, which is shaping the light that comes into the camera and focusing it on that image plane. All the focal length actually means is it means when you are focusing at an infinite distance, right? If you're focusing far away on most, like on a typical lens, that would be like more than 25 feet, 25, 30 feet. At that point, it becomes focused from there to infinity. Everything is in focus. So when you're focused at infinity, uh, the distance the lens has to be away from the image plane for it to create a perfectly sharp image on that digital sensor or image plane. That's the real definition of focal length. And the bigger the focal length, and then again, the further away the lens is from that image plane. So you can see down here, we have a focal length of 50 millimeters. And you can imagine sort of a camera here in this box. And another thing to realize is, of course, the relative size of my subject is larger with a longer focal length. That should make sense intuitively. A telephoto lens is going to have a long focal length, and a telephoto lens, as we know, takes it takes something a distance from us and brings it near in the camera when we're composing. So it makes sense that things that for a given focal length, the bigger the focal length, the bigger the subject is going to appear in the frame. So another thing when we're thinking about optics is, when we're thinking about focal length, is that it affects angle of view. And all angle of view means is like how wide of an area do you take in, and when you're taking a photograph with the camera. So now my video cam screen, the angle of view is coming out from here, and it's coming out along these edges, right? And so if we measured that angle, we would get our angle of view for this particular lens that we're using on the webcam. And this works the same with your lens on your camera. So the more telephoto a lens, the smaller the field of view, right? The narrower it is, because we're taking something very far in the distance and we're just focusing on that. Whereas a wide angle view is taking it a wide angle. And that's really all you need to know. It's not really important that you know how many what the angle of view is for a particular focal length lens, unless you really need to know that for a specific situation. But most of the time you don't. Here's a visual of what it looks like if you're standing in the same point and you change lenses and you slowly increase the focal length. You go from seeing a lot of things in the foreground with a wide angle lens and things at a distance seem very far in the distance, to slowly zooming in and being able to get closer and closer to that, in this case, a distant city skyline, so that is filling the frame pretty much entirely, and all the things in the foreground are gone. And so this is a 300 millimeter lens view, and this is a 20 millimeter lens view. That's a 15 times optical zoom. That's a pretty significant difference between those two focal lengths, and boy, you can really see it in the composition that results. This is the same idea, it's just in color and a little bit prettier. But as you increase that focal length, it's like putting on a zoom on your camera. Your telephoto is moving in towards it, and so you can really see it closely. Here's a good example. I'll read this as a sense of how the lenses do really distort and change the way your subject looks. So you see on the image on the left and the image on the right, it's the same person. They take up the same amount of size in the frame, but they look. This portrait is very different between these two lenses. So your choice of lens focal length determines both the angle of view and the relationship between the scene's foreground and background. Here, a 28 mm wide-angle lens on the left takes in more of the scene and exaggerates the distance between the subject and the wall behind him. But it's not very flattering because it distorts the subject's features. Look at how strange his ears look. Look at how much larger his nose looks compared to the image on the left, compared to the image on the right. Sorry. A 105 mm telephoto lens in takes in less of the scene and compresses the distance between the subject and the background, so the wall seems closer and the portrait subject looks more natural. One other thing I'd like to talk about with optics is the comparison of focal length versus distance to subject. So how does the camera or the image look different if I change my focal length? Um, well, here's an example. So if I stand in one place and I essentially go from a wide angle lens and take in this bird nest, this this bird sculpture, and this bird cage, it looks like this on this floor. But then if I move into a normal focal length lens, everything gets bigger, but it gets bigger proportionally the same. And then in this telephoto lens, as I'm getting quite close, notice the relationship between the sizes of everything. It's pretty much the same. It all gets bigger together. Whereas if I change, if I use the same focal length lens, but I change my distance to the subject. If I start farther away, then get a bit closer, then get a bit closer, then actually the proportions of how big each of my subjects in the frame is changes differently from each other. So for example, the thing to notice here is the relative size of the bird cage to the egg in the nest. So here, the nest is considerably smaller than the bird cage. As I get closer, it gets bigger, but the bird cage gets maybe slightly bigger, but not very much. And then if I get even closer, the bird cage, which is the closest thing in the foreground, gets so big that it's the same size or bigger than the bird cage up here, which again has not really changed much in size. And so that shows you that it's not the same thing if you sit in one place and zoom in your lens and get closer in compared to you keeping a normal, say, focal length and walking closer to your subject. The point of view and the perspective is going to shift. The relationship of different objects in that frame are going to shift. And so this is a really good example of how there are a lot of subtleties of the way optics works in a camera. And those things, to appreciate those things, take a lot of exposure and just exploration and experimentation. But it's good to see this in action with a specific scene or set so you can study these things. So I hope you learned a little bit here and it was useful. Thank you.